Hello everyone, today we will discuss the medium-hard binary tree problem. LeetCode problem 98, validate binary search tree. First, let's see the description of the problem. Given the root of a binary tree, determine if it is a valid binary search tree BST. A valid BST is defined as follows. The left subtree of a node contains only nodes with keys less than the node key. The right subtree of a node contains only nodes with keys greater than the node key. Both the left and the right subtrees must also be binary search trees. So because we only have less than and greater than, we don't have equal to. So if a binary tree has duplicate nodes, then the binary tree will also be invalid. And let's see an example here. Let's see this example too. So the value of the root is 5, which means all of the left side nodes has values smaller than 5. So 1 meets the requirement. And here we go right side. So for all of the nodes on the right side needs to be greater than 5. However, we say 4 is smaller than 5, so this node is invalid and then the whole tree will be invalid. Actually, beside this node is also invalid because although this tree is smaller than 4 meets the current parent requirement, however, 3 will also be greater than 5. So this node needs to meet the requirement of the parent nodes of the parent node. So this node needs to meet the requirements of the ancestor nodes. So because 3 is smaller than 5, then it's also invalid. Because we need to pass the range from the nodes, not only to pass the range to the direct children, but also need to pass the range to the children of the children nodes. So we will have the lower bound and the upper bound in the recursion function as parameters. So we use the recursion algorithm to solve the problem, and then let's go into the recursion function. Here we have the common iteration function here. So if we go left from the current node, then we need to pass the value of the current node as the upper bound to the left side nodes, to the children and to the children of the children. So we will have the current value as the upper bound and leave the lower bound as it is. Similarly, if we go right side from the current node, we need to pass the current value of the nodes as the lower bound to the children of the current node and to the children of the children's. So we will have the current value here as the lower bound. Here is our iterations of the recursion. And for the current layer, we will have like 3 conditions. Firstly, if the current node is an empty one, we will return true because all of empty trees and all of empty subtrees are valid. Then, if the current value is smaller or equal to lower bound, we will return false because for the current value, it needs to be strictly larger than lower bound and strictly smaller than the upper bound. So for current value smaller or equal to lower bound, or the current value greater or equal to upper bound, either one condition will be invalid. So we will return false. Because all of the left subtrace and all of the right subtrace needs to meet the requirement to have a valid binary search tree. So we have the AND here. So all of the left side nodes need to meet the requirement, and all of the right side nodes need also to be meet the requirement at the same time. In this case, we will solve this problem, and let's see. We submit the solution, and it succeeds. Yeah. For the time and space complexity, we have time complexity as O(n) because we need to traverse all of the nodes once, and we have space complexity as O(n) because we need to store nodes in a stack due to the iterations of the recursion. So we have O(n) for both time and space complexity. That's all for today. Thank you very much for your time. See you.